So in our last tutorial, we prepared this employee project table for normalization by putting it in first normal form. And the table is in first normal form because every cell in the table has atomic values. You can see every cell in the table has atomic value. And we took this table, which is in first normal form, and we wrote it using relational notation. So the table was given a name, which is project. Every attribute is listed next to the name of the relation, and the primary key is shown through underlines. The attributes are underlined, and in this case it so happens that there are no foreign keys. If there were any foreign keys, they would be shown using dotted underlines. So we started with this table in first normal form, and we had a discussion in the previous tutorial where we said that this table has anomalies, update, insert, and delete anomalies, and that's why we are going to continue and try and normalize it. Okay, so after making sure that this table is in first normal form, the next question we ask ourselves is this table also in second normal form? So we started in first normal form, and we ask ourselves, is it also in second normal form? So what does it take for a table to be in second normal form? Excuse me. So the first thing that must happen is that the table must be in first normal form. So there are no skipping steps. You put the table in first normal form, that's where you start, and then you check, you look at the list of dependencies that you have for the table and check that there are no partial dependencies. Okay, so when do you have a partial dependency? You look at the primary key of the table, and it has to be a composite primary key. If the primary key is not composite, when is a primary key composite? When it consists of more than one attribute. So only when the primary key is composite is it possible for a table to not be in second normal form. If the primary key just consists of one attribute, it is automatically in second normal form. So check that the primary key is composite, and then look to see if there are any partial dependencies. Simply means that you have non-key attributes that depend on a part of the primary key. The primary key is composite. It consists of more than one attribute. So all you do is you check if non-key attributes in the table depend on a part of the primary key. So let's continue with the example that we are looking at and see where things stand with this table. So here we have the project relation. It is in first normal form. We already know that. So we are asking, is this table in second normal form? Now notice that the primary key of this table is composite. So that's the box that you see over here. The primary key is project number plus employee number. I need both those attributes to uniquely identify any row in the table. Okay, and I can see that from this diagram, because this box project number plus employee number identifies hours. Unless I have both these two attributes, I cannot identify hours in the table. So the primary key is composite. I can see that from this list also. If I go through the list, I can see that project number will give me project name, employee number will give me all these non-key attributes, these ones. Okay, job class will give me charge hour, but only if I know project number plus employee number can I assign hours. Okay, so this non-key attribute I can only determine if I know both project number and employee number, and hence the primary key of this table is composite. Okay, so now when I know that this primary key is composite, I look at the functional dependencies and ask myself, are there any partial dependencies? In other words, are there any non-key attributes that depend on a part of the primary key? Okay, so for example, I can see project name. It depends on project number only. All right, and project number is not the full primary key, it's a part of the primary key. So that's a partial dependency. Similarly, employee last name depends only on employee number. All right, it doesn't depend on the full primary key, it depends on a part of the primary key, hence that's a partial dependency. The same thing with job class. Job class depends on employee number, and hence it depends on a part of the primary key. The hourly rate, the hourly charge also depends on employee number. So it depends on a part of the primary key, not the full primary key. It's only assign hours, the hours that I worked on the project, that particular non-key attribute depends on the full primary key. So here we have a table which is full of partial dependencies. Okay, and anytime a table has partial dependencies, it is not in second normal form. Okay, and the reason we want to get rid of partial dependencies, so to put a table in second normal form, you have to start chopping it up to get rid of partial dependencies. Okay, so and why do we want to eliminate partial dependencies? Because if they remain, then the update, insert and delete anomalies that we talked about will remain. Okay, and we saw that for this table here. For example, if the hourly rate for database designers were to change from $105 to $150, you would have to change it here, you would have to change it here, you would have to change it here, otherwise you would have inconsistent information. Similarly, if the hourly rate for systems analysts were to change from $96.75 to $100, then you would need to change it here and here, otherwise you would have inconsistent information. So anytime there are partial dependencies, okay, then when you start putting in records, that information starts repeating itself. You get redundancies because of the partial dependencies. So just think about how this table might evolve. Suppose you had 50 projects and you had this kind of a structure. Just try to visualize what kind of redundancies would arise because of the partial dependencies. So because the partial dependencies give rise to those modifications, those insert, update and delete anomalies, we get rid of them. So how do we get rid of the partial dependencies? Now that we have checked the table, it was in first normal form, but it is not in second normal form. So we have to get it in second normal form. And it's a two-step process. Okay. And in the first step, so this is the first step, okay, we take the composite primary key. So remember in our example, the composite primary key was employee number and project number. Those two together are the primary key. Okay, so we take each attribute of the primary key. Remember, a violation of second normal form can only arise when the primary key is composite. So there must be more than one attribute. So what we do is, first we list these attributes in the composite primary key on a separate line. So I put employee number here first, and then I put project number here second. If the primary key had 3 attributes, I would list the third attribute just after this one. Okay, and at the end, right below everything, I write the composite primary key itself. So I have employee number and project number. Okay, so I list these 3 separately. Okay, and then this in the second step, this is the first step. List each of them separately, and now you can see where we are headed with this. Each of these will become a separate relation. So we took the one relation, one big relation, and we are now chopping it up into multiple relations, each of which will be in second normal form. So they will not violate the partial dependency rule. So in the second step, we look at each of these determinants, okay, separately, and then write down all the dependent variables. So your functional dependencies are X determines Y. So I look at each of these in turn, and then I write down what they determine. I write down the right-hand side. So we'll go back to the functional dependency diagram. So we have employee number determines employee last name, job class, and charge hour. Okay, so we have employee last name, job class, and hourly charge hour. Okay, so where did I get this information from? I got this information from the functional dependencies that we had identified. So employee number determines employee last name, job class, and charge hour. That's what I wrote. Okay. Similarly, project number, I will write down again, going back to look at my list. Project number determines project name. I can see that from the functional dependencies. So I just write project number determines project name. Okay. And the last one, I go back to the list. Project number plus employee number determines assign hours. Okay, so we have these three separate tables that we have here. All right, so we've taken this one table called project, and we have broken it up into three tables. So here's table 1, here is table 2, and here is table 3. Okay, and if you just look at the setup of these three tables, you can see that there will not be any partial dependencies. So if you look at table 1, all the non-key attributes are dependent on the full primary key. So in the second one, the non-key attribute is dependent on the full primary key, and in the last table, assign hours depends on the full primary key. So I've taken this one table called project, and I've chopped it up into three tables. Okay, here they are. I've chopped it up into three tables, each of which is in second normal form. So you look at the first table, this is the non-key attribute. It depends only on project number. Similarly, the employee table, each non-key attribute, this is a non-key attribute, this is a non-key attribute, this is a non-key attribute. It only depends, each of these non-key attributes depends on the full primary key. This is the primary key, this is the primary key. Okay, so if you look at each table separately, there are no partial dependencies. Okay, so for example, if I draw the dependency, if I write down the dependencies for this third table, it would look like this. I have not much space here. So project number and employee number is the primary key, and it determines assign hours, the hours worked on the project. So there is no partial dependency, do you see? And if I draw the dependencies for this employee table, I would have employee number, and it determines employee last name, it determines job class, and it determines charge hours. So just by looking at this picture, do you see these non-key attributes? They depend on the full primary key. They don't depend on a part of the primary key. So I have these relations now chopped up that are in second normal form. Okay, so here we have so we have the three relations. So we took that one relation called project, and now we have chopped it up into three relations, and each of these relations is in second normal form. All right. So how are these relations connected? Now, just because we have chopped up that one table into three tables, we have to be able to splice them back together. For instance, I want to be able to find out which employee works on a particular project. If I give you the project number, you should be able to tell me all the employees who work on that project. So simply by chopping up that one table into three tables, I have gotten rid of anomalies, but I cannot lose information. I still must be able to recreate the information that was there in the original table, and that's where the foreign keys come in. If you look at these three tables, you can see this assignment. The primary key of this table is project number plus employee number, but project number is also by itself is a foreign key which connects it to the project table. Employee number is a foreign key that connects it to the employee table. Okay, so we have foreign keys and primary keys. The foreign keys, you go back to your understanding of the relational model. It's the foreign keys that allow you to connect. So we have project, which has project number. We have employee, where the employee number is the primary key. And then we have assignment, where the primary key is project number plus employee number. So that's the primary key. Together is those two attributes together is the primary key of assignment. However, if you look at each of these separately, so project number by itself is a foreign key that links back to project. Employee number by itself is a foreign key that links back to employee. So we have split this one table into three, but whenever information requires me to connect the three tables back together, I have the foreign keys that connect back connect the three tables back into that one table that we had. So we have gotten rid of the anomalies, but in a way that allows me to recreate the information that was there in the original table. And most of the time, once you get a table into second normal form, most of the time you're done. But there are situations where even getting it into second normal form will cause problems. So just to show you a quick example, going back to these three tables. So all these three tables are in second normal form. However, if you look at the employee table, so employee table is in second normal form because every non-key attribute is dependent on the full primary key. There are no partial dependencies. So the employee table is in second normal form. However, you still have anomalies. So for instance, if you have database designer and their salary changes to $150 an hour, you have to change it in two places. Similarly, if the system analyst's hourly chart changes, you have to change it in two places. Okay, so this update, insertion and delete anomalies still remain even though employee is in the employee table is in second normal form. So we have to clean it up. We have to split the employee table again. And the reason that these anomalies arise is because of what are called transitive dependencies, and that's what we will see in our next video tutorial. So we will stop here for now, and what we have shown in this tutorial is how to get a table that's in first normal form into second normal form to get rid of update, insert and delete anomalies. But we concluded by saying that although most of the time this will be the end of the normalization process, there are certain situations where getting a relation to second normal form doesn't get rid of all the anomalies. You may need to go to higher normal forms, and that is what we will see in the next tutorial.